The first thing I need to do in order to draw this angle in standard position, because it's in radians, is I want to go through and mark each of those angles on the axes. I want to label what they are in radians, but I'm not going to use my normal radian measurements. What I'm going to do is I want everything to have a denominator of 6 because that's what my problem has. So 0 is going to be 0 pi over 6. For this one up here that would be 90 degrees, we're going to do half. So half of 6 is 3, so we're going to do 3 pi over 6. Then we multiply our number times 1, so that would be 6 pi over 6. And then at the bottom here, we multiply by 1.5. So I'm doing 6 times 1.5, which is 9, so 9 pi over 6. And then I'm doing 2 times 6, so that would be 12 pi over 6. So just a quick recap so that everybody's really clear on what just happened. I take my denominator, which is 6. For this one up here, I multiplied 6 times 0.5, which was 3. So that's where this 3 came from. Over here, where it would be 180 degrees, I did 6 times 1, which is just 6. So that's why this is a 6. The 9 came from doing 6 times 1.5. That was 9. So that's this. And then the 12 came from 6 times 2. So you're always going through and you're multiplying by 0.5, 1, 1.5, and 2. And you always start at 0, of course. Okay, so now I can figure out, I have 5 pi over 6. Now I'm just looking at my numerators really. 5 is in between 3 and 6. So I'm going to draw my angle in quadrant 2, and 5 is closer to 6 than it is to 3, so I'll draw it like right here. And then I'm going to draw my rotation going counterclockwise, and I'm going to label my angle 5 pi over 6.